We're now going to be looking at the second part of our solutions discussion, discussing electrolytes versus non-electrolytes. Electrolytes, when dissolved in water, allow electrons to flow. They produce ions when dissolved in water, and most importantly, electrolytes are acids, bases, and salts. The opposite of that would be non-electrolytes, which do not conduct electricity. Electrolytes can, when they dissolve in water, dissociate or separate from each other into positive and negative charges, which allow for the conduction of electricity. For example, salts, which are metals and nonmetals, dissociate to positive and negative ions. Acids, which start with H, dissociate into positive and negative ions. And bases, which end in OH, dissociate into positive and negative ions. They all conduct electricity. Acids are substances that release the H plus ions in aqueous solutions. Usually, they start with an H, and they turn blue litmus paper red. Bases are substances that end in OH, and they convert red litmus paper into blue. Salts are produced by combining metals with nonmetals. They do not start with an H or end with an OH. And what happens, they have no effect on litmus paper because they're not acids or bases, but they do conduct electricity. So as a summary, acids start with an H. They turn blue litmus paper red. They usually neutralize bases. They start with an H usually. Bases end with an OH, turning red litmus paper blue, blue for base. They neutralize acids, and they typically end with an OH. Salts break down or dissociate into metals and nonmetals. And, for example, like sodium chloride. Acids, bases, and salts all conduct electricity. The pH scale is another way to determine whether a substance is an acid or a base, or if it's neutral, and how strong it is. The pH scale goes from 0 to 14. Acids range from 0 to less than 7. Stronger acids are closer to 0. Weaker acids are closer to 7. Bases are greater than 7, up to 14. And very, very strong bases have a pH of 14. Very weak bases have a pH of slightly more than 7. And a pH of 7 is neutral. The scale goes up by a 10-fold factor. For example, if we go from a pH of 2 and we compare that to a pH of 3, the pH of 2 is 10 times stronger, or the substance is 10 times more acidic than a pH of 3. When I'm comparing an acid with a pH of 2 with a pH of 6, the acid with a pH of 2 is 10 to the 4th time, or 10,000 times stronger than the substance with a pH of 6. So litmus paper is a way to identify acids or bases, and if your litmus paper does not change colors, then the solution is neutral. So red litmus paper introduced to an acid turns red, and blue litmus paper becomes blue from red if it's in contact with a base. Indicator solutions also give more specific information as to the pH of the substance. For example, if I put this indicator of thymol blue in a solution and it turns red, then it's a very strong acid with a pH of 1 to 2. If it turns blue in that solution using thymol blue, then the pH is between 10 and 13. As you can see here, we can do that, and we can sometimes combine indicators as well. For example, if I combine bromothionyl blue with thymol blue and the color was orange, then the pH would be 3.